Okay, now in this question we're being asked to calculate the pH of a saturated solution. Now there's nothing too fancy here. This is there's going to be, obviously, when this dissociates in water, we're going to get one mercury ion like this and two hydroxide ions. And just from the usual formula, Ks equals 4x cubed, we just have to divide that number by 4, find the cube root, and we should end up with a value for the solubility where S equals 2.08, and that's going to be times by 10 to the negative 9 moles per litre. Now the only thing to keep in mind here is that this is a hydroxide ion concentration, so we need to do a little calculation to work that out. Now the one thing obviously to keep in mind is that this is for 1 mole, and obviously when we're looking at hydroxide there's double the concentration, so this number needs to be times by 2 first, and that's going to equal 4.16 times 10 to the negative 9 moles per litre. And then if we work out the pH of that, we should get something in the region of 5.62. Okay. Now the next part's more important. What assumptions have we made in this? Now remember, there are some. Basically, in any solution of water we have this dissociation of water that goes on, where we get a small amount of hydroxide ions and a small amount of hydronium ions being produced, and we tend to ignore that, and we can only ignore that if that is relatively low. Now in water we get at neutral pH we'd have an amount 1.0 times 10 to the negative 7 and 1.0 times 10 to the negative 7. These are relatively small concentrations, but if we look at the calculation that we actually got here, 4.16 times 10 to the negative 9, that's even smaller still. So these numbers are much bigger, and we tend to only ignore those if this concentration here is much greater than those. So we can't ignore these if these concentrations are relatively large compared to the one that we calculate, and that is the case here. So that assumption is not valid in that case, and therefore this pH here, we can't really assume that that's correct either. So in this case we'd have to assume that the pH is more based on this value of hydroxide ions than it is on this one. So in fact you could do a calculation where you could combine 1 times 10 to the negative 7, the dissociation of water concentration, plus this one calculated, and work that out, but you could effectively say that the pH is really neutral at this point, because this value is going to be so low as to be insignificant. And that's that question complete.